Talking about some segments and circles and what we got going on here. This is pretty easy. There's two main things to remember. The first is when the segments are really chords inside a circle. So when we have two chords intersecting inside a circle, what we can say is the product of the pieces of the chords. Namely, if I look at A to E, the green piece, and E to C, the blue piece, when I do that product, it's going to equal the product of the orange piece and the pink piece. Now, notice that the blue and the green together make one chord up, and the orange and the pink together make the other chord up. So I taught this for so many years, and the way kids remember it easiest was this. Ready? Make sure you're looking at the cursor here, because they're in the same chord. This times this equals this times this. So you take the pieces of the chord and multiply them by each other. So this times this equals this times this. And that's what we would say in class. This times this equals this times this. And it works. And, I would like to say I should be more specific and say something like, well, the product of the segments of each part of the chords are equal. But students didn't remember that nearly as easy as this times this equals this times this. So what am I talking about? So what I'm talking about here is that this times this, QR times X, right? Because that's one chord, is going to equal 3 times 16. So those are the pieces of the other chord. So the pieces of one chord multiplied, 9 times X, is going to equal the pieces of the other chord multiplied, 3 times 6. So 9 times X is 6 times 3. So 9x is 18, dividing by 9, x is 2. It literally is that simple. Your turn. Okay, so this times this, 2 times 10, is going to equal this times this, 4 times x. So 2 times 10 is 20, equals 4 times x is 4x, dividing by 4, x is 5. Your turn again. Okay, this time, ready? This times this, 9 times x, will equal this times this, 12 times 3. So 9x is equal to, 12 times 3 is 36, dividing by 9, x is 4. So that's segments inside the circle. It really is that easy. It seems like it ought to be harder. It is not. That's all there is to it. Okay, what about if the segments are outside the circle? So the best way I know of to do this is, if the segments are outside the circle, whoa equals whoa. Whole times outside, WO. Whole times outside equals whole times outside. Let me take you through an example. Ready? The whole piece is 12 times its outside piece 4 equals the whole piece 16 times its outside piece x. So whoa equals whoa. Whole times outside equals whole times outside. So 12 times the outside piece 4 is going to equal 16, the whole piece, times the outside piece x. 48 is 16x. Dividing by 16, x is 3. Your turn. Okay, so again, outside the circle, so segments outside the circle. Now, very important that we remember the difference between a question about angles and a question about segments. If we're doing a question about angles, the angles half the difference in the arcs, but this is a question about segments. So when we think segments, we think whoa equals whoa. So the whole times the outside, 20 times 4, will equal the whole x times the outside 5. So that makes 80 equal to 5x. Dividing by 5, x is 16. Okay, well, sometimes they mess around a little bit with where the x goes, but just stick with whoa equals whoa. You won't have a problem. Go ahead. Okay, so whoa equals whoa, whole times outside equals whole times outside. So if we look here, this whole segment from R to Q is 20. How did I know it's 20? Because the outside piece is 9 and the inside piece is 11, so the whole thing is 20. Times the outside piece, 9, equals the whole piece, which is x plus 10, times the outside piece, which is 10. So 180 equals, distributing the 10, 10x plus 100. Subtracting 100, I get 80 is 10x. Dividing by 10, x is 8. So that's whoa equals whoa. Whole times outside equals whole times outside when applied to two secants like RQ and RT. Now, sometimes people like to make a separate formula when it's a tangent. And they like to say, oh, well, that tangent, which is AB squared, is AC times AD. But it's still whoa equals whoa. Because in this case, this oddball case, the tangent is the whole and it's the outside. So that's why it ends up being squared. Ready? You give this a shot without me, and then we'll go through it. Okay, so as we've said many times, whoa equals whoa. Whole times outside equals whole times outside. So on the left-hand side, the whole length is 16, right? The 9 plus the 7. So that times the outside, which is 7, and I made a mistake here. If I ever did one of these without you and it came down to me not making a stupid mistake, you would say somebody's impersonating my teacher. So 16 times 7, which I should easily be able to do, is 112, I believe. Yep, 112. So x is equal to the square root of 112, which I need to go to insert. Well, I don't know why it doesn't want to do this for me. Here we go. Ready? In case you need to know how to do this. 112 equals x. So if we say to leave it in simplest form, x will equal the square root of 112. And then if it wants me to say what exactly the square root of 112 is, well, not exactly, but rounded, say, to the nearest tenth, it is 10.6. So let's get back to playing this guy in a slideshow so we can give you a better mistake on my part. I am, like I said, never got 100 on the Regents. Always ace Regents. Lots of high grades above a 95. Never got 100. And I believe the only test I didn't get a 90 on was Spanish. I think I got like a 80 something. All right. So whoa equals whoa. Whole times outside equals whole times outside. So the whole thing, 16, times the outside piece, which is 7, the mistake I had made was putting a 9, equals x times x. So 112, because 16 times 7 is 112, is equal to x squared. X is the square root of 112. And a lot of times they'll say that that'll be the choice. That's the answer, and that's fine. But sometimes they'll round it to the nearest tenth. Putting it in the calculator, it'll tell you 10.6. Okay? Okay, try this one. Go ahead. Okay. Whoa equals whoa. Whole times outside equals whole times outside. And in the case of the red tangent x, the whole and the outside are the same exact thing, making the x squared. So 16, which is the whole length, times 4 is equal to x, which is the whole length, times x, which is the external part. So 64 is x squared. Square rooting both sides, x is equal to 8. So what is our summary for segments? Well, intersecting chords inside a circle, this times that equals this times that. Okay, I can't, it's just the way that students memorize it best. Next, segments outside the circle. Whole equals whole. Whole times outside equals whole times outside.